everyone, I am Dr. Kiranmayi, Area Chair and Assistant Professor, Department of Management Studies, Digital Transformation and Operations, School of Business, Aditya University. And in this lecture, I am going to talk about multiplication theorem of probability and its applications. So, we have various theorems on probability based upon the types of events. We have to apply that particular theorem. And in the previous lecture, we have understood what is probability and what are the various types of events, what are the various types of probabilities. All these things we have understood in the previous lectures. And coming to this present lecture, in this lecture, I am going to talk about multiplication theorem. So, coming to multiplication theorem, when this particular theorem comes into picture and when we can make use of this multiplication theorem. So, multiplication theorem comes into picture when we are dealing with events, a kind of dependent and independent events. When there is a classification exists, that is dependent and independent events, then we need to use the concept that is multiplication theorem of probability. Coming to the independent events. So, multiplication theorem consists of two cases. So, one case is in case of independent events, when the events are independent events, and the other case, that is case 2, is in case of dependent events. First, before understanding multiplication theorem, so we must understand what is an independent event, what is a dependent event. So, independent event, the event, if we toss a coin, the occurrence of head in first toss is independent of occurrence of head in the second toss. Suppose if I toss a coin for the first time, I may obtain either head or tail. So, the probability of getting head in the first toss is 50%. And if I toss the same coin second time, again if I calculate, the probability of getting head is 50%. 50% chances are there for getting head in the second toss also. So, here obtaining head in the first toss, obtaining head in the second toss, both are independent events. So, if that is, in simple words, we can say that if the happening of one event does not impact the happening of another event, then the two events are said to be independent events. And in case of independent events, how to calculate the probability of happening of both the events, that is given by P of A intersection B is equal to P of A into P of B, that is multiplication of the individual probabilities gives the probability of happening of both the events. So, this is and suppose if there are 3 independent events and if one is interested in knowing happening of all the 3 events together, then we can use multiplication theorem in case of if all the 3 events are independent events and the multiplication of the product of their individual probabilities gives the probability of occurrence of all the 3 events. So, this is how we can make use of multiplication theorem in case of independent events. So, for example, suppose the weather condition in 2 cities. So, the weather condition in one city is not going to impact the weather condition of the other city. So, the weather condition in 2 different cities are independent events. Likewise, suppose there is a pack of cards. Imagine there is a pack of cards consisting 52 cards. If we draw one card, so the probability of selecting one card out of 52 cards is 1 by 52. And if I have drawn one card from the pack of 52 cards and the probability of getting is 1 by 52. and if I replace again the card in the pack of cards, and again if I select another card from the pack of 52, again the probability of getting one card is 1 remains the same, that is 1 by 52. Here in this case, the selection of one card in the first draw is independent of occurrence of one card in the second draw is not going to get impacted by the first draw. So, that is another example for independent events. Likewise, tossing of a coin. If I toss a coin for the first time, getting head is 50%, and in the second toss also probability of getting head remains the same, that is 50%. That is, probability of getting head in the first toss is not going to impact probability of getting head in the second toss. So, the two events, that is getting head in the first toss, getting head in the second toss, is not going to be affected by the first toss. So, both the events are said to be independent events. So, these are the various examples for independent events. So, in case of independent events, the probability of getting both the events, the probability of happening both the events is given by multiplication, simple product of their individual probabilities. And coming to the second case, so that is in case of dependent events, there we have another kind of probability, that is conditional probability. See, it is called conditional probability because happening of the other one event is dependent upon happening of the other event where there is a condition. Say for example, if there are two boxes containing box 1, box 2 containing two different color balls, red, white. For example, first box contains 1 red and 3 white. Second box contains 3 red, 2 white balls, for example. So, if I want to select white ball, the probability of getting white ball directly dependent upon the selection of the box, because both the boxes are not having same number of white balls. Since first box contains 3 white balls, suppose if I calculate getting white ball in the from the box, so in order to select the white ball, first what is the condition we had here? Selection of the box. So, the probability of getting white ball is dependent upon the probability of selection of the box. So, here the happening of the event of getting white ball is dependent upon selection of the box. Therefore, here the two events are said to be dependent events. So, the conditional probability is represented as P of B given A, that is B is directly dependent upon A. Here we can define event A as a selection of box and B as getting or selecting white ball. Since getting white ball is dependent upon the event selection of the box, so that is why the probability of getting white ball here is called conditional probability, which is denoted as P of B given A. And in case of conditional probability, the probability of occurrence of both the events P of A intersection B is given by P of A into P of B given A. So, this is how we can use multiplication theorem in case of dependent events. And coming to the example. So, the same example, if we consider drawing a card from the pack of 52 cards. For example, if I want to select a pack of 52 cards consists of two color cards, that is black and white. 26 black cards, 26 white color cards. Okay. So, total 52. Suppose I want to select one white card, for example. So, total number of cards are 52. Okay. So, out of 52, getting one white card, the probability of getting one white card is given by 26 by 52. Okay. Suppose if I replace, first I have selected one card and the probability of getting one white card is 26 by 52. If I replace this card again in the pack of cards, again the probability of getting white card will remains the same. Therefore, here getting white card in the first draw, getting white card in the second draw, both are independent events. Since I am replacing the card which I have picked up in the first draw. Suppose if I do not replace the card which I have picked up in the first draw, then only, so out of 22 white cards, imagine I have picked up one white card in the first draw. Then total for the second draw, total 51 cards remains, and out of 26, 25 cards only remains. Therefore, the probability of getting white card in the second draw is termed as conditional probability. Now, it is given as, therefore, in the second, for the second draw, total number of cards is 51, and out of 51 there are only 25 white cards, because since I have picked up one white card in the first draw which I have not replaced, now only 25 white cards are there. Then the probability of getting white card in the second draw will be 25 by 51, which is not like the same. In case of first draw, it is 26 by 52, which are not the same. Okay. So, this is called, this is best example for dependent events, that is getting white card in the second draw is dependent upon the getting white card in the first draw. So, in such a case, the two events are said to be dependent events. Suppose if I do not get white card, for example, if I do not get white card in the first draw, then 26 cards remains, but total number of cards will be 51. Then probability of getting white card in the second draw will be 26 by 51. Suppose if in the first draw, if I obtain black card, then the probability of getting white card in the second draw will be 26 by 51. So, this is how getting white card in the second draw is getting impacted by the first draw. Therefore, the two events are said to be, here the second event, that is getting white card in the second draw, is dependent upon the first draw. The events are said to be dependent events. So, in such a case, we come across with conditional probability. And let us coming to the application part of this multiplication theorem. In case of, so as I said, we have two cases, that is independent events case, dependent events case. So, suppose if we consider tossing of a coin or rolling a die. For example, I want to get 6 in the, I am going to toss a coin for 3 times, say for example. Okay. So, first time if I throw the die, getting the probability of getting 6 is 1 by 6, and in the second throw, probability of getting 6 will be 1 by 6, and in the third throw, probability of getting 6 will be 1 by 6. Therefore, probability of getting 6 in first throw, probability of getting 6 in the second throw, probability of getting 6 in the third throw is given by 1 by 6 into 1 by 6 into 1 by 6. Since getting 6 in the first row is getting 6 in the second row is independent of getting 6 in the first row. Getting 6 in the third row is independent of getting 6 in first and second row. So, we have to multiply to get the probability of to calculate the probability of getting 6 in all the 3 rows is given by simple multiplication of their individual probabilities. And in case of dependent events, so for example, here we have an example. A bag contains, there is a bag which is containing 5 white balls and 3 black balls. 2 balls are drawn without replacement. So, what is the probability that both are black? So, first suppose I want to select 2 balls out of 8 balls. So, for example, if I get black ball in the first draw, for example, getting black ball in the first draw, probability of getting black ball in the first draw is given by, so how many balls are there for the first draw? In total the bag is containing 8 balls, 5 plus 3, 5 plus 3, total 8 balls are there. So, out of 8 I want to get black ball in the first draw. That is total number of favorable cases. So, probability is given by favorable number of cases by total number of cases. So, total 3 black balls are there. Therefore, probability of getting black ball in the first draw is 3 by 8. Now, probability of getting black ball in the second draw. So, now I have not replaced, it is a kind of problem without replacement. So, in the first draw, imagine I have obtained black ball. I have picked up one ball, that is black ball. Therefore, I have not replaced it. Therefore, for the second draw only 7 balls remains. Out of 7, I have to pick up another ball now, and there are 2 black balls remains for the second draw. Therefore, probability of getting black ball in the second draw will be 2 by 7. Now, the question is, what is the probability that both are black balls? Therefore, P of, suppose if I take it as A first draw, P of A intersection B is given by 3 by 8 into 2 by 7. That is 3 into 2, 6 by and 56. So, 6 by 56 is the probability of getting black balls in the first and second draw. So, this is how we can apply multiplication theorem in case of independent events and in case of dependent events. In this present lecture, we have discussed what are dependent events, what are independent events, and how to apply and what is the conditional probability, and when to apply multiplication theorem, how to calculate the probability of occurrence of both the events using multiplication theorem and its applications. Thank you.